Hello everyone, welcome back. So in this particular video we are going to cover graph, and in the next video we'll be having the practice session. So in this particular video we are going to cover graph, and in this we have already covered some basic graphs in our previous video about uniform, non-uniform. These already have been taught in the last videos of different type of motion, distance, displacement. These graphs has been already been taught, but here we are going to see a quick revision of the previous topic, as well as we are going to see the area under the curve, all those things. Okay, so let us start with the very first graph, which is the position time graph. First thing is, why do we study graph? See, the graph gives you a systematic information. I know, image, it forms an image in your mind. So if you remember something with image, you can actually retain it in your mind for a longer time, or you can know it more accurately, or if just link this with an example. You want to read a rough copy, or you want to read a very fresh copy? Definitely you want to read a very fresh copy. Similarly stands with the written data and the graphical data. Written data actually seems to be very boring, or say it seems to be very not too interesting. But if graph is given to you, that graph gives you the sensation of the feel of the data. So that's why we study the graph, either in motion, either in the real life. Okay, so let us study the position time graph. First is position time graph. Okay, now in position time graph, here is the displacement, here is the time, and remember that distance is equal to displacement here, because let me explain you about motion in 1D, 2D and 3D. Since motion in 1D is that types of motion in which only one coordinate is available. There is three axes: x-axis, y-axis and z-axis. Z-axis is perpendicular to the x and y-axis. Okay, so if one of the three axes is involved in the motion, then it is a one-dimensional motion. If two of the three axes are involved in motion, then it's a 2D motion. If all of the three coordinates are involved in the motion, that is called 3D motion. Now, how we can relate it with an example? I'm moving on a straight line. So, can you say that my displacement is 5 meter in a straight line? I'm also moving in a straight line. My distance is also in a straight line. I'm not changing my direction. So here distance is equal to displacement, and the similar way the displacement is equal to distance, then the same way speed is equal to velocity. Okay, so in this way distance and displacement, speed and velocity in 1D graph remains everything same. Okay, so this is ST graph. Now slope will give us, what slope will give us? This will give us velocity. So write it down, that slope of ST graph, this is vector I am representing, graph is, slope of ST graph is velocity. Okay, this is velocity, and the slope can be calculated by using the formula tan theta, or if coordinates is given, y2 minus 1 y1 minus x upon x2 minus x1. So this is the formula of calculating. Okay, and this is a uniform motion because it's a straight line. If you will see the instant at any time, every time the body is covering the equal distance in equal time, that is why we call it as uniform motion. But if the graph was a little curved or parabola, then it would be a non-uniform motion, because body is covering different distances in different time. Okay, so let us discuss. Now comes the most important part of your graph, that is velocity time graph. That is very important. Velocity time graph, first is again is velocity time graph. Okay, velocity time graph. Okay, velocity time graph. So here, what will be the actually the figure? Let us draw it. Now I have learned to draw these straight lines on the board. Okay, so I don't need any scale or anything, any equipment to draw straight lines because I have learned. So this is time and this is velocity. Tell me, what will slope give us? What will slope give us? If let us draw the two graphs. Okay, so what slope will give us? The slope will what will give us? Will give us velocity upon time. So velocity upon time, I have told you that y upon x is slope. Y upon x, y एक्सिस में जो क्वांटिटी होगा, y एक्सिस में जो क्वांटिटी होगा divided by the x axis quantity will give you the slope. So velocity upon time, that will give us acceleration. Yes, remember that change in velocity will give you acceleration. Here velocity is changing. Velocity is changing. So here is what? Acceleration. Okay. So note it down that slope of velocity time graph gives acceleration. Okay. And slope can be calculated by y2 minus y1 upon x2 minus x1, or by using the formula directly tan theta. You can use both the formulas if depending upon the situation. Okay. Now tell me one thing. Tell me one thing. What this area will give us? This area. What this area will give us? Tell me one thing. What this area will give us? This area will give us what? This area will give us displacement. So write it down that area under velocity time graph is displacement. Okay, so when you will calculate displacement here, and how do you calculate displacement? Suppose this is actually given you the figure is like something like this. It's and it is like here, again it's here. So calculate the area. यहाँ पे जो भी figure दिखे उसका area calculate कर दो. For example, अगर यहाँ मुझे square दिखता है, I will apply the area of square. Similarly, if I actually get rectangle here, then I will apply length into breadth. Okay, so in this way we can actually proceed. So, and now comes the increasing acceleration, decreasing acceleration, uniformly increasing acceleration, uniformly decreasing acceleration. Now this is very confusing. How we can actually learn it? See, this is a increasing acceleration. If you see it, it is increasing. ये हर time पे increase हो रहा है. This itself is an increasing acceleration, but this is a uniformly increasing. This is uniformly increasing. Okay. Now I will draw another graph. If you have noted down, then it's good. And if I actually draw a graph like this, then what will happen? See. If I am drawing that a body जिसके पास कुछ initial velocity था, वो यहाँ से अगर body ने start किया, what this suggests? This suggests what? It is decreasing acceleration. क्या हो रहा है? देखो हर जगह पे velocity की value घटते जा रही है और last में आके zero हो गया. So this is the decreasing acceleration. Okay. Now if I actually draw a line like this. What is this? This is uniformly decreasing acceleration. Whenever you will see a straight line, definitely it's a uniform one. Okay. Now comes the negative acceleration. So I am drawing this graph. But for this you need the quadrant. आपको quadrant पता होना चाहिए. This is the first quadrant. Here y is positive, x is positive. This is the second quadrant. This is the second quadrant where x is negative, y is positive. This is third quadrant. In here, both x is negative, y is negative, and this is the fourth quadrant where actually uh, this is the fourth quadrant. Here x is positive and y is negative. Okay, so now here what we'll do is just we'll gonna fill the data. Okay, fill the data. If I say that a body is going under negative acceleration, now how will you represent it? This is the graph. It's going negative acceleration. This is a vt graph. vt graph. Now it's going, पहले मानते हैं कि उसकी कुछ इनिशियल वेलोसिटी थी, फिर वो धीरे 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 उसका वेलोसिटी नेगेटिव में जाने लगा. देन इट विल बी लाइक दिस. दिस इज व्हाट, यहाँ पे y एक्सिस हमारा नेगेटिव है. इट्स अ नेगेटिव वन. यस, इट्स नेगेटिव. नाउ इफ आई से दैट अगर कुछ इस तरीके का केस मिल जाए हमें ग्राफ में, मैंने एक केस बताना मैं भूल गया यहाँ पे, दोनों ही केसेस में अभी देख लेंगे. क्वेश्चन से भी बहुत कुछ यहाँ पे, क्वेश्चंस तो बहुत होते हैं इस पे, और क्वेश्चंस ज़्यादा मिलेंगे भी. और ये वाला अगर एक केस मैं डिस्कस करूँ तो यहाँ पे क्या होगा, ये वेलोसिटी है, ये टाइम है. सो हियर नो एक्सेलरेशन इज देयर, कोई एक्सेलरेशन नहीं है. व्हाट इज एक्सेलरेशन? एक्सेलरेशन इज चेंज इन वेलोसिटी. यहाँ पे देख लो, यहाँ पे देख लो, यहाँ पे देख लो, यहाँ पे देख लो, यहाँ पे देख लो. द टाइम रिमेन्स gets changing, but your velocity remains constant. So here velocity is positive constant. Okay, got it? Now if let us say इस तरीके का हमने कुछ बना दिया, अगर ये यहाँ पे अगर वेलोसिटी हमारा इस तरीके का है, then this is a negative constant. वेलोसिटी नेगेटिव है ना, ये तो हमारा y एक्सिस नेगेटिव होता है, मैंने अभी बताया. ओके, सो आई होप यू हैव गॉट दिस. ओके, नाउ दिस आर द सम केसेस, velocity time graph, and all are completed. Okay, so I have almost actually give you all the situations. Okay, now the next is acceleration time graph. अब ये क्या होता है? What is this? This is a very interesting thing. See it. Next is acceleration time graph. What is acceleration time graph and how it is different from the other graphs? Now let us draw this. This is acceleration, this is time. If you have listened to my every crux of this topic, if I have teach you something at once, then also you will be able to retain it in your mind. Okay, so acceleration time graph. So here यहाँ स्लोप की बात नहीं होती है, यहाँ स्लोप की बात नहीं होती है, यहाँ किस चीज की बात होती है? यहाँ पे बात होती है एरिया की बात. ये एरिया. So this area of, write it down, that area of acceleration time graph, acceleration, again we are doing mistakes after mistakes. So area of acceleration time graph gives us change in velocity. Very important, change in velocity. Okay, so this area gives us change in velocity. Velocity को change, velocity में change. Acceleration is defined as change in velocity. So change in velocity is v minus u. So v minus u by t, v minus u, change in velocity को represent करेगा हमारा acceleration time graph. So this was a very simple topic. Okay, so here we have covered about all three types of graphs, and I don't think there is any other graph. If it is there, then please actually let us know in the comments. Okay, I think it is done. Now ये जितने भी हम लोग ग्राफ लगा रहे हैं, ये सारे ग्राफ कब के लिए हैं? ये सारे ग्राफ जो हम लोग लगा रहे हैं अभी, that graphs are only for when acceleration is constant. sorry एक चीज मैंने equations of motion में मैं बताना भूल गया था, and that was like if somebody tomorrow somebody asked, one of my friend asked me that tell me if acceleration is not constant in the problem, what we will do? what we will do. So write it down that if acceleration is constant, then we will apply equations of motion. Okay, and if acceleration is not constant, then integration is applied. What is integration? No need to know, right now. Just know that अगर acceleration constant नहीं होगा, integration differentiation लगाते हैं. Okay, so I am ending this class here only because I think that already this has been, class has been expanded. Okay, so in the next video there will be a practice session, and along with that I will bring you DPQs for practicing. Okay, so there will be 10 to 15 questions, and in the last video there were 14 or 15 questions in equation of motion. So thereafter graph, and after that the last topic, or yes, and there is one more topic, that graphical actually the graphical way of deriving the equations of motion, that is also left. So in the next video we'll be actually covering that, and we'll be practicing some questions. Okay, till then, goodbye.